or good afternoon. Perhaps it's good evening. I don't know. What am I, CC here? That's not what's going on here. It's Al Trucker, and I'm here with another wonderful video where I'm going to talk about a sphere. This sphere here, I used in my yesterday video when I talked about a spherical triangle. The one with 390-degree angles that add up to 270 degrees, not 180 degrees like in a planar triangle. So we don't have to belabor that point. What I did was I added something to the triangle. I kept on going with a line this time, and this line that I'm showing you here is what's called a great circle. A great circle is the line that goes all the way around a sphere. I see it stepped a little bit, so if people want to get really persnickety, they'll see that like the way it wraps around the tack that holds it in place has it sitting slightly offset. I don't know if I could fix that, but I think only the most pedantic will get upset about that. They'll see that it is a continuous circle, and if it weren't for the fact that I'd wrapped it the wrong way on the tack, it would pretty much be a perfect great circle. So this line is the shortest distance between any 2 points, like these two here, is made up of this. And I wanted to point that out. This line, this straight line between these 2 points, is the shortest distance. And furthermore, perhaps more importantly than this, is that the line is an arc, but it is conforming to and constrained by the surface of the sphere. You cannot draw a shorter line between these 2 points and be constrained by the sphere. You could tunnel through and make something that is shorter, but this arc segment between these 2 points on the sphere, that's the important thing. They're on the sphere. This is the shortest distance. And if you want to go, the shortest distance between one point is to just stay there. But if you wanted to continue around this line, which is a straight line on the sphere, it's straight when you look at it this way, more or less. It's exactly straight, but I realize the camera doesn't pick things up as well as it could. This line is a straight line, despite the fact that it's also a circle. But it conforms to the outside of the sphere. It's constrained by the surface of the sphere in spherical geometry. I'm not sure why this is difficult for people to understand, but I realize that it is. And when I realized people were having trouble understanding this concept and getting caught up in words and the difference between spherical and Euclidean geometry, I thought, maybe I can explain this. Maybe I can't. And perhaps my message is not making it through to people. And I've certainly spoken to some people fairly recently that probably will not and cannot get this. But I did want to get the message across. And these great circles are the routes that are taken as close as possible. There are other factors, but airplanes and ships travel on great circle routes when and where possible. There are other factors for navigation, like jet streams and currents, trade routes, trade winds, that sailors and pilots will know about, that change the way we actually travel a little bit. But generally speaking, the best way, the fastest way to travel between 2 points on the outside of a sphere is a great circle. And our Earth is a sphere, and perhaps some people want to disagree with that. And so I brought another sphere I have. This is a really old globe that has countries The political boundaries on it are not accurate. This is an old one, and it's a fairly cheap school globe, the kind that you buy to have in your home, and it's from a number of years ago. But the shape of the Earth hasn't changed in that period of time, amazingly. And I wanted to show to people that I thought maybe what I'd do is I'd take a little piece of thread here and show that when you pick any 2 points on this globe and you want to travel between them and you take this line, I don't know if the line will show up. It sort of does, right? If you take any 2 points and draw a line between them, it's a straight line. And I don't know if it'll show up, but it is an arc that conforms to the outside of the sphere. So I think this is a little bit hard for people to understand, but I also hear people saying they don't understand how it could be that you could have 2 points that are antipodal to one another. So like if you're here, this is in the southern part of Africa, the antipodal point would probably be somewhere up in the Pacific Ocean based on where I've got my fingers here. I may not perfectly have them. And this is a hard thing to show. But yeah, you can get 2 points that are this way. I also have noticed, this is kind of cool, that on this thing here, you can see markings here, and you can see the degrees, and they match up here. So this is 0 degrees of latitude, 10 degrees, 20 degrees, 30 degrees. So, and then you can come up to 40 and then 50. 50 is pretty close to where the border is between my country, we call it Canada up here, and the United States, which is another country people have heard of. And that's where we're starting to get pretty close to what people call the North Pole. And 80 degrees is way up here in the Arctic. 60 degrees is the line of latitude where the territories of Canada start, pretty much. I can't remember if that's the exact line. I'm pretty sure it is. And 70 degrees, you're starting to get pretty far up here. Now, I know people say this place doesn't exist. I want to show it to you here. Antipodal to the Arctic is the Antarctic. There's this continent down here. It's not a wall. It's a continent. It's a landmass. And it's down here. And that's like 90 degrees right at the pole. 80 degrees, 7 degrees, 60 degrees of south latitude. And this is the opposite of that line up in Canada where we differentiate between the provinces and the territories. The northern territories are north of 60, as they say. This is a line of latitude. Now, lines of latitude are not gray circles. Lines of longitude are. And a line of longitude, if we come up here, we'll come to a nice spot. Like, here's a place called Australia. I think this is a country people have been to. And I believe people in Australia, they hold their globes like this. I'm hoping that some of our Australian friends can watch this and let me know. I know Mark Reed's in Australia. He's in Perth, which, if I remember correctly, is over here somewhere. See if I can find it. Yes. I'm pretty sure he lives near Perth. That's over here. And then I also know there's a couple of people in New Zealand around. And that's this place here. And we may not have as many people from other places, but this country here is Argentina. It's also in the south. And then this is actually, I believe a friend of mine is traveling here. This orange country here, I don't believe it's actually orange. A friend of mine has been traveling and sending some pictures from South Africa, which is also in the south here. And if they look out this way, they're looking towards Antarctica. They can't see it because the curve of the Earth blocks it. but they're not so far away. They're still pretty far away, though. Like, they're further away from it in South Africa than I am when I'm in Canada from the North Pole. They're much further away in South Africa from the South Pole. But they're still much closer to the South Pole than I am. Anyway, perhaps this has been helpful. Perhaps it has not. It's always hard to say. But I do appreciate people checking in. I hope this has been an enjoyable video. And I hope you've learned something. And if you haven't, leave comments as to why. Thank you. And look and subscribe. Look and describe. I can't remember what we're supposed to say. I'm not much of a YouTuber, as you probably have noticed. But what I am is a person who likes to get things right, if I can, and correct misunderstandings. And if I've got something wrong, I want to fix that. Thank you.